So let's take some notes about finding the space diagonal now. Remember, this is just using the Pythagorean theorem in three-dimensional prisms, boxes, cylinders. I know it's a little blurry. Hopefully you have a printout of the copy so you don't have to try to sketch all these diagrams. It can get a little tough, right? All right, our learning target is I will be able to find the length, and that's a measurement, right, of a space diagonal. And we'll call it D for the most part. In this case, I think they're calling it C. All right, so if we have this rectangular prism, I know sometimes it can get, my eyes shift on me and I can't tell what the front and the back is. You could think the front was here, or you could think the front was here. I'm going to say the front is right here, okay? So this is the front of our box, okay? Right there. We're trying to find the length of the diagonal that is in the lower left corner and goes through the middle of the box to the upper right-hand corner. Okay, so this is our space diagonal. Okay, over here, we're going to change this to D. We'll call it D right here. Okay, now in a rectangular prism, a space diagonal. Oh, I spelled it wrong. There we go. Is a line that goes from a vertex, which is just a corner, right, of a prism or box, through the center of that prism to the opposite. I'm going to say it twice, don't freak out. Opposite vertex. So what do I mean by opposite? Well, if this is in the front, what's opposite is in the back. But if this is the bottom, and we're talking about the top, it's opposite and opposite. It's not only to the back, but to the top. So it happens twice. Okay. So we are going to use Pythagorean theorem to help us figure out that distance. And Pythagorean theorem, remember, a squared plus b squared equals c squared, where a and b are the legs that form the right angle. C is the hypotenuse across from the right angle. Right? So the leg squared added to the other leg squared will give me the hypotenuse square. All right, so let's do this example here where we're talking about this prism. They want us to find from here to here. This might look familiar to you. Okay. So I'm going to get myself a little ruler here and draw that out. Right there. Okay, so we're going to call it small letter D for diagonal. So we are going to first, though, look at triangle ABC right here. And that triangle is on the floor of this prism. So we look there and we want to calculate this distance from A to C. From A to C is the hypotenuse along the floor of this box. Okay. So how are we going to do that? Well, this is a leg, so 12 squared. And this is the other leg, 28 squared. You know, from this vantage point, it doesn't look like that's a right angle, but if you were looking down on that, right angle is what's forming right there at the box, right? Okay, and that would equal c squared, which is going to be this green part right here, right? Maybe I'll try to be consistent there. All right, well, hopefully we have memorized that 12 squared. Now 28. I don't think you would have that memorized. I don't either, but I know it from earlier. So when we add these together, that's what c squared is. the green one. And that's way too long, right? So what we're really looking for is the square root of that. Okay. Now, if you looked at the video before, I probably found the approximation of this, but we're not going to do that this time. We're going to leave it because it can be kind of convenient to leave it, all right? Okay, so we're going to go back now, and now we're going to talk about triangle ACG. ACG is here, and that is a space triangle because it's taking a three-dimensional space in here, okay? So this triangle, like a little wedge in there. And if we wanted to calculate the length of AG, which is this hypotenuse of the space triangle, well, now we've got this is our leg, and this is our hypotenuse. So I'm going to label on the diagram that this was the square root of 928 exactly. All right, so let's use our new leg of 16 squared plus hypotenuse is now a leg, 928 squared. That's going to give me that diagonal squared. Okay. Now, 16 squared, we did not have you memorize, but it is 256. And you see now I didn't try to approximate this. If I left it exact as a square root of 928, square root squared, it's just going to be 928. So save myself some time. All right, if I add these together, it's going to be 1184. Again, that's too long, right? We have to square root that for it to make any sense. So it's the square root of 1184. Is that diagonal? I'm going to write it up here. Now, what do we notice about these steps? I mean, if you think about this result, right? Isn't it this the same thing? These are all the same thing, aren't they? So I don't know if you notice that. But is this, if this is really a squared plus b squared, that's kind of the c squared, isn't it? And they gave us the diagonal. So this is something that you don't need to know. So if this kind of throws you off a little, don't worry about it. We need to go through this process by finding the hypotenuse on the floor of a box and then using it as a leg to find that space triangle's hypotenuse, okay, otherwise known as a diagonal. But if you're ready for this, I want you to think about instead, this was the length, this was the width, this is the height, and this is our diagonal, right?